In this video, we will look at user datagram protocol, which falls under the transport layer. A few quick questions first. A recap, a transport layer provides logical communication between processes, and we have seen that the internet supports a few transport layer protocols like the UDP, TCP, RPC, RTP. UDP is the bare bones version of the transport protocol. It is an extremely simple protocol, nothing fancy about it. So UDP provides just the multiplexing demultiplexing capability over the best effort service model of the network layer. In fact, it does a little bit more. I'll get to that shortly. So because it is operating over best effort service, the UDP segments can get lost, they can get duplicated, they can get delivered out of order. UDP does absolutely nothing to address any of these issues. As mentioned earlier, this is a connectionless multiplexing demultiplexing. In other words, the UDP sender and the receiver do not exchange any information to establish any connection. So each UDP segment is handled independently of the others. So at the transport layer, you don't care whether this particular UDP segment belongs to a flow or not, because you're not even maintaining any state. You just treat the segment by itself and deliver it to the right process. Who would want such a service without any fancy frills? Can you think of any reasons where such a service may be useful, the transport layer service? In fact, there are quite a few reasons. The fact that there is no connection establishment which can lead to the delay, by which I mean that before you start sending data at the transport layer, both the sender and the receiver exchange some information to establish the connection. A little bit like what we saw in the virtual circuit networks. So this connection establishment can take up some time. So when you don't have any connection establishment, as in UDP, you can save on time. For example, DNS uses the UDP because the DNS packets are very few. So just to send a few packets, you don't want to send additional packets to establish connection. That will increase the DNS response time. The fact that UDP is so simple that it does not maintain any state at the sender of the receiver permits a server to support lot more clients than other transport protocols that maintain state. In other words, a server that uses UDP versus a server that uses TCP, the UDP server can support more clients. The UDP header, which we will see shortly, is really small. It's just 8 bytes. That means the amount of overhead you are incurring per packet is also very less. On the contrary, the TCP header is 20 bytes and even more if it supports options, which leads to a lot more overhead. And you need this additional information because you need to handle few other things which UDP doesn't handle. UDP provides no congestion control. This is a mechanism that is employed by the TCP. We'll cover it in more detail later. But what basically this means is when you are sending data, if you feel that the network is congested, you do not send data. In other words, your rate is dictated by the congestion in the network. On the other hand, UDP doesn't care about congestion. You just blast away data as fast as you want. Well, this is good for you. You are being selfish. It's not good for the network, but in some cases, this is useful. Another feature which UDP does not implement but TCP does is retransmissions, because TCP has to support reliability. So UDP does not incur any retransmission delays, and this can be very useful for real-time applications because in retransmitting some earlier packets, you are delaying the later packets. So voice over IP, online games, these all typically run over UDP. Mainly because they can also tolerate some amount of losses. So all these applications that use UDP, if they want some additional features that UDP does not provide, what should they do? They just have to implement it themselves. So here are a few example protocols that make use of UDP. We have seen DHCP before. It relies on UDP. RIP is also a protocol that uses UDP. We didn't cover domain name service. We will see more of this later. This also uses UDP. SNMP, which stands for Simple Network Management Protocol, also uses UDP. So this is a protocol that is used for managing nodes such as switches, routers, printers, servers, and so on IP networks. Why is the emphasis on IP? all these need to have an IP address so that you can log in to configure them. I'm not going to cover SNMP. So here is the UDP segment format, very simple. So this is the header and this is the payload. So you can't do without the source port and the destination port, so that information is included. Typically the client often chooses a random port, whereas for the server listens on well-known ports. The length field here specifies the total length of the particular segment. And then there is checksum. This is the additional service on top of multiplexing, demultiplexing that UDP provides. This checksum is optional in IP version 4, whereas this is compulsory in IP version 6. Why do you think that is? Because in IP version 6, the IP header has no checksum, so it's good to do it at a higher layer, that is at the transport layer. So this checksum basically ensures the correctness of the message, and it uses the same algorithm as the IP checksum. So over what fields is the checksum calculated? This is calculated over the UDP header, the body, this is the application layer data, and something called the pseudo header. What is the pseudo header? It is made up of 4 fields in total. 3 fields actually come from the IP header. This corresponds to the protocol number, source IP and destination IP. And then you are repeating the UDP length field. In other words, this UDP length field is counted twice when you are calculating the checksum. So why is this done like this? You basically want to include the pseudo header to ensure that this particular packet is delivered to the right host. What if some intermediate router changed the destination IP address and recalculated the IP checksum and passed it? So this packet is finally going to come to this particular host, which is not the correct destination. So where will you check that this packet is not destined for the host? If the transport layer includes a checksum like this, then you will know, because your original checksum at the particular source itself included the destination IP address. Thereby you will know now that this packet is not for me, and the checksum will fail, and then you're going to drop that particular packet. So why are these unnecessary fields included? I think this has got more to do with the checksum implementation, where you want to align them on 32-bit boundaries. So there was some space left, so they decided let's just include UDP length again. So to summarize, UDP is a very simple transport protocol. It provides multiplexing, demultiplexing, and a very simple error detection capability. It finds good use in many protocols in spite of its simplicity, mainly because of its simplicity. Simplicity is good in certain cases, while it may not work in other cases.